Good morning, children. Here we are into the second session of our chapter Force and Energy. In the session 1 of this chapter, we have learned about force and effects of force, different types of force, and what is friction, and advantages of friction and also disadvantages of friction. So in the second session, we are going to learn about energy and different types of energy and uses of energy and about levers. Yes, let us get into the chapter and know what it is all about. Now, basically, let us know what is energy. From your lower class, you have been learning what is energy. What is energy? Energy is a source that helps you in growing, isn't it? That is what we have learned from the smaller classes. Here when you define energy, we say energy is the ability to do work is called energy. If you have fever and you're very tired, can you do some work? No, isn't it? Of course. So here we call it as the ability to do work is called energy. And here there are different forms of energy. Not only the energy in the body is called energy, there are other type of energy which we find in our surroundings. So let us see what all are these energies. The first one is our heat energy. Yes, by looking at the picture itself, you are very clear that, isn't it? It is heat energy. The source of heat energy are burning fuels such as coal, LPG, kerosene. All these are having heat energy in them. So because of which we use them for cooking. We have gas stoves. We have that old model that is that in olden days how people used to burn the firewoods and cook their food. And also we have kerosene stoves. And later now we have the gas stoves, that is our LPGs, isn't it? So what is the use of all these things? These things are helping us in cooking food. Okay, so this energy is called the heat energy and the source is coal, LPG and kerosene, and it is used for cooking food. Second one is light energy. Light energy helps us to see things around us. Example, electric bulb, lamp, tube light and candle are the source of light energy. And the ultimate source of light energy is our sun. Sun gives us light energy because of which we can see all the things around us. Isn't it? In daytime we don't go for any electric bulb or any lamp or any tube light nor a candle. Yes, without anything we can see the things around us with our naked eyes. So who is providing light at that time? It is the sun. So here for light energy we have source as electric bulb, lamp, tube light and candle. Along with that the ultimate source is sun. The third one is the mechanical energy. So mechanical energy that an object has because of its position, that is called the potential energy. And also the moving object, that is the movement, is called the kinetic energy. The object at rest will have potential energy, that is the energy that is saved, and kinetic energy, the energy that is moving. Okay, and this energy is called mechanical energy. Okay, so when you look at the example, water stored behind a dam has potential energy which gets converted into kinetic energy as the water falls from the height. So water that is stored in the dam is having energy but it is not using it. But though it is not using, it is having energy, isn't it? So for example, when you are standing for a running race, you may think that person is very thin or very lean. How can this person run? We may thinking, but when the person runs only we come to know he has lot of energy, isn't it? So the person at rest is having potential energy, but when it's turned into movement, it becomes kinetic energy, the conversion of potential energy and kinetic energy. This energy is called the mechanical energy. The next is the electrical energy. Appliances such as electric bulb, tube light, radio, television, computer and washing machine uses electrical energy. We know this very clearly, isn't it? Electrical energy is electrical energy is generated at a power station and supplied to our houses. So this we know very clearly. I think I have nothing to explain about it much. No, we know our radios, TVs, computers, all this work when you put on the switch, isn't it? Yes, we plug on to the switch and put the switch, immediately our television or computer, tube light or electric bulb, all this burn or work. Okay, and we also know that this electricity is coming from the KEB, isn't it? And for the KEB, from where it is coming? It is coming from the power station and it is supplied to every house. For 2 hours, if you don't have current, what you will do? Immediately you call up to the KEB office to ask, why sir, why there is no current in my house? From 2 hours I am waiting to do my homework, isn't it? Yes. So this is what happens with the electric energy. So when electric energy is not to be found, we know that power station is responsible for the electric supply. Okay, the next one is the wind energy. Power of the moving air, it utilized with the help of windmills to generate electric energy. The wind energy is converted into electric energy with the help of windmills. Most of the village side you can see this windmills. There will be a long windmills at the top of some mountains or something. When the wind is blown very hardly, then the windmills turn. Okay, so the wind energy is converted to generate electric energy, because of which they create electricity to those villages. So those remote villages where they don't have proper facility to give the power supply from the power station, so those villages will get help with the windmills to generate electricity. Okay, the next one is sound energy. Portable audio players, televisions, radios and loudspeakers are the source of sound energy. Musical instruments such as guitar, tabla also produce sound energy. So obviously we know that without a music player we all are upset. I can challenge you to say all of them in our class love music, isn't it? Yes. So we know that depends on the person's attitude whether they listen to soft songs, hard songs or pop songs or rocking songs. That is your wish. But still everybody loves music. And there are some children who are fond of this musical instrument. Mostly it will be guitar, isn't it? Or some will be interested in flute. So this is called the sound energy, that sound coming from the audio player or television, isn't it? That is audible to our ears. Okay, that is the sound energy, but the source is this guitar, tabla and so on, isn't it? Okay, this is the sound energy. So here we have covered with the 6 energies. First one is heat energy, light energy, mechanical energy, electrical energy, wind energy and sound energy. So we have 2 more energies to be seen. We'll turn up the page. The next energy is the solar energy. I hope everybody knows about this, because nowadays we are seeing solar water heater everywhere. In most of the houses we see this solar water heater which is used to heat the water in time, right? Instead of using a gas geyser or electric geyser or something like that. Yes, solar energy, the energy that we get from the sun is called the solar energy, and it provides heat, light, hot water and electricity. Yes, we use solar cookers, solar stoves, solar water heaters and solar light also, isn't it? There are some lamps that they keep in the outside for the morning, and night they use it as a UPS supply, isn't it? Ultimate power supply. Yes, so nowadays everything we are trying to convert into solar energy because the energy is free of cost. Isn't it? Solar energy, do you pay anything for the solar? Because the sun is giving the energy. Only the machineries are costly. Maybe to put solar water heater to your house, it may cost. But energy is free of cost from the sun. Isn't it? Yes, this is the solar energy. The next one is geothermal energy. The energy that we get from the heat of the earth is called geothermal energy. Both these energies are natural energy. The geothermal energy used to generate electricity. Yes, with the help of this pressure that is there inside the earth. Okay, we know about gravitational force. That is the force that is present inside the earth, in the depth of the earth. Like that, there is an energy also in the depth of the earth, which is called as the geothermal energy. Due to the pressure and the temperature that is present inside the earth, this energy is generated. And with the help of this energy, they can generate electricity. As how wind energy is converted into electric energy, solar energy is converted to electric energy, even geothermal energy can be converted into electric energy. Next we have renewable energy and non-renewable energy. Renewable energy, the energy can be regained, and non-renewable energy, the energy that cannot be regained. That is the product that gives us energy can extend away. So one among the best example of renewable energy is our natural energies, as we were speaking about natural energies till now, isn't it? Yes, these natural energies are renewable energy. That is, every day we get it from the nature. So we see here the energy that can be renewed or replenished over periods of time is called renewable energy. Solar energy, wind energy and geothermal energy are the example of renewable energy. Today if you use the energy, tomorrow again you will get that energy back. Yes, tomorrow also you will get solar energy. Day after tomorrow also there will be sun for you to give you solar energy. After 10 years you ask for solar energy, will the sun give? Of course, isn't it? Yes. So periods together you will have energy that is coming back and back to you. These energies are called as renewable energy. Energy that cannot be renewed or replenished over a period of time is called non-renewable energy. Energy obtained from fuels, fossil fuels such as coal, petroleum is non-renewable energy. So we cannot say when the coal may get over, when the petrol may get over for us to create LPG, isn't it? So we cannot predict how long these energies will be there with us. After 10 years, if there is no petrol, no coal, and we cannot get those energies. So these are called as non-renewable energies. Is it clear, children? Now we have simple mission. There are certain missions in our life without which we cannot move our daily lives itself. Every day we need one among these missions to do our simple mechanism. Especially if you ask your mothers, they will tell you better. Yes, if she wants to tighten any cooker, immediately she search for a screwdriver. Will she ask the shopkeeper to tighten the cooker and give for her? No. She directly uses a screwdriver. Immediately she takes the screw and tightens her cooker. Even you do the same, isn't it? You want to cut a paper. Will you take it to the shopkeeper to cut the paper? No. We use a pair of scissors. Scissor is always available in our house. Immediately we take a scissor and start cutting it. So these are called as simple machines that are available in our house with our some certain energy. So let us see what are this. We use various tools such as pair of tongs, pair of scissors, a wheelbarrow, etc. to make our work easier in our daily life. Of course, isn't it? These tools are called as machines, like your screwdriver, hammer, and your cutting plier. See, all these things I'm sure everybody has at home. A machine can be defined as a tool that makes our work easier by helping us overcome a large force, or called load, by applying lesser force called effort. Okay, let us read it once again. Okay, a machine can be defined as a tool that makes us our work easier by helping us overcome a large force called load. So our large force what we apply on the object is called load, and we have force that is applied is called effort. Okay, if the load is more, effort is more. If the load is less, effort is also less. Let us see what is this. A simple machine uses a single applied force to overcome a single force. A complex machine consists of two or more simple machines working together. There are 6 types of simple machines. So let us look into what are the different types of simple machines. Here we have one is lever, wheel, axle, pulley, incline plane, screw, and wedge. So hope so all these items we have seen. So sometimes if you are confused with the name, as we go through it, we'll come to know what it is. First one, let us see what is a lever. A lever is a rigid rod arranged in such a manner that it can move freely around, and a fixed point is consists of the following 3 parts. First one is fulcrum, load, and effort. So fulcrum is a point in the center in between the load and the effort. Okay, when the load is on the one side, effort is on the other side. So in between you have the fulcrum. Okay, this fulcrum fixes a point around which the rod moves. Load, it is the object on which the work is being performed. Effort, it is the force that needs to apply on the rod in order to process the task. Now look at the first class lever, children. Here you can see the effort is on the other side, load is in this side. Yes, you can see load as yellow, effort as pink. When the effort is put on the fulcrum, can you see the fulcrum? Yes, it is in center, that is balancing both the effort and the load. When the effort is applied, the load moves. For example, you can see the scissor here. Yes, when the effort is put on the back, that is where you put your fingers, and that is connected to a fulcrum. With the help of fulcrum, we are able to cut the object, that is a load. Are you clear now? By looking at this picture, you may find it difficult, but as soon as you look at your scissor, you are very clear that it is the working of the first class lever. Okay. Yes, for the first class lever, effort is on one side, load is on the other side. Both are connected by the fulcrum. Now look into the second class lever. See, in the second class lever, fulcrum is in the first edge, effort is in the last edge, but the load is in the center. Okay, so for us, our example is the wheelbarrow. When you look at the wheelbarrow, we can see this wheelbarrows in the cement workplaces, isn't it? Yes. So the fulcrum is the connection between the effort and the load is given in the front, so that it pushes the object, and the effort is put in the back, that is pushing the object, but the load is in center. Okay, so this is the wheelbarrow, and you have a bottle opener. When you look into your bottle opener, you can see that the load also will be in the top, your fulcrum will be in the first edge, and the effort will be in the last edge. Nut cutter, nutcracker. Have you seen the nutcracker? Yes, that is also one example of second class lever. Now this is the third class lever. In the third class lever, fulcrum also will be now edge, effort will be in the center, the load will be in the second edge. So for the best example is a pair of tong and your stapler. For a stapler, where do you put the pressure? You put it in center, yes, but the connection is in the first edge, because the connection between this end of the stapler and that end of the stapler. Yes, when you put the pressure in the center, immediately the stapler will pin up your books. So more than a pair of tongs, stapler is a good example for your third class lever. Yes. After lever, the next example is wheel and axle. By looking at the picture itself, you know very clearly what is the work of wheel and axle. A wheel and axle consist of a wheel rigid attached to a rod. When the wheel is rotating, the axle also rotates. For example, the wheel and axle of a screwdriver and doorknob and steering wheel of a car. Yes, when the wheel is moving, you can see the rod also is moving. Okay, this is the example for a wheel and axle. This is also a type of energy applied on a object because we have a simple machine. So wheel and axle is one type of a simple machine which we use every day. Next one is pulley. A pulley consists of a wheel which is ground brim and a rope, a chain or a belt running around the groove. The wheel rotates around a stationary axle. A pulley can be two type, fixed and movable. For best example for pulley, if you have seen the grinding mill, okay, where you go for your chili and coriander. Have you seen rice grinding? Yes, if you have seen, you can see this pulley work. They type that wire over a pulley and they switch on the light, switch on the bulb. Immediately the pulley is pulling that rope. And one more manual example is your well. When you fetch water from the well, you put your effort this end, you can fetch the water. But through the help of pulley, if the pulley is not there, you have to put your own effort to pull the water. But with the help of pulley, the pulley will rotate so that your rope is being coming easily, isn't it? Here the pulley is of two types. One is the fixed pulley and the other one is movable pulley. So fixed pulley, as I told you, it's an example of the grinding mill. Okay, from movable pulley you can take an example of water fetching pulley. Here the axle of a pulley is fixed to some kind of support such as a hook or a wall, or one edge of the rope is attached to the load. This type of pulley changes the direction of force, makes work easier. It is used to lift a bucket of water from the well or to raise the flag of the trolley flop. Next one is movable pulley. The movable pulley, the axle is not fixed to any kind of support. It's free and movable. The load is directly attached to the pulley. The type of pulley helps to lift heavy objects with easier effect than the fixed pulley. It is usually used in combination of fixed pulleys. For example, crane. Crane uses both fixed and movable pulley to lift objects. Is it clear, children? So that you got a very good example of a fixed pulley and movable pulley. Okay. The next one is the incline plane. So all of you have seen this incline plane in your parks, where you go stand up and you leave your body free so that you come and settle up down. Isn't it? We have seen slides. Yes, this slides is a good example of inclined plane. A slope or a flat surface raising at the angle or to move heavy object with less effort is called the inclined plane. See, when you are bringing down some object from the tempo, you could have seen they put like a stair stripe, small inclined plane there, so that the heavy boxes, when they push it from there, immediately it comes and settles down. There is no need of someone carrying that object from the tempo to the ground, isn't it? Though this is called the inclined plane. For example, you can easily come into this, and there is also inclined plane. The ramps in the hospital, can you see? They take the stretcher to the ramps. one side you will have stairs, in the same place you will have some rigid places like an incline only, isn't it? Most of you, if you have seen, it will be better. You will get a good idea about what is inclined plane. Other than that, you can see the slides in the playground, where you call it as the incline, where you can skid and come out, isn't it? Yes. The next one is the wedge. A wedge is a form when two inclined planes are joined together. Such a one edge is sharp and the other edge is bulged. When you take the two inclined planes in two directions, try to bring it close, then it becomes a wedge. A knife is an example of a inclined plane, and you can see the axe that is given in your textbook. That is also a very good example of a wedge. You can see, compare the inclined plane and the axe. You can see inclined plane is one edge of the axe. When you combine such two inclined planes, immediately you can find the axe there, which is a wedge. Obviously, this wedge is used almost in most of our houses, isn't it? The last one is a screw. A screw is another type of inclined plane. It's formed when an inclined plane wraps around a straight rod-like structure. A screw is a spiral groove surface with the pointed edge. It is used to hold things together. The hatching edge of some light bulbs is an example of a screw. Yes, can you see the bulb? Yes, beneath the bulb you can see a screw which will hold the object to the holder. We have holders at our home. With the help of the holder, we put the screw inside the holder so that our bulb stays stiff there. I think there is no much more explanation for this, because everybody know how a bulb looks and how the holder of our bulb also is. Okay, with the help of these two, we can easily tell that how a screw would be. Okay, this, as I told you, all the simple machines are used in our daily life, and with the help of all the simple machines, our everyday moves on easier. Yes, children, here we end up our session 2 with the energy and the simple machines. In the next session, I will give you the notes for this chapter 9. Until then, let us have a good day, children. Bye.